The Air Rules smartphone scenario is a line balancing problem, although it doesn't look a lot like a line balancing problem because it doesn't give you any information about the tasks that need to be assigned to the assembly line. Let's take a look. It takes a total of 400 seconds for one technician working alone to assemble one Air Rules smartphone. Now that is information. Not about any individual task in the assembly, but I'm writing sigma t for the sum of the task times. Apparently, however many tasks there are, they add up to 400 seconds. Oh, okay. Now, what else? However, Air Rules manufactures its smartphones with 20 technicians staffing a 20-station assembly line. Oh, this assembly line is already balanced, I guess. It's already designed, and what we were just told, capital N, right, is the parameter, the number of stations. Well, we were just told that there was 20. Okay, I'm just storing that information. Producing one smartphone every 30 seconds. That is another important data point. One smartphone every 30 seconds means this assembly line that's already been designed has a cycle time of 30 seconds, because that is another way to define cycle time. If it is creating one phone every 30 seconds, then everybody on all those 20 stations has a budget of 30 seconds to do whatever it is that was assigned to them. That's the cycle time. All right, now, if it's already designed and it's already operating, then what is it that we're supposed to do in this line balancing problem? Let's look. How many hours must Air Rules operate its assembly line to create 1,200 smartphones daily? Well, that's really just logic. It's not a formula or anything. They're saying they want to create 1,200 phones, and we were just told, we were discussing, that one smartphone is produced every 30 seconds. So if I said 1,200 times 30, I get a large number. Basically 360,000 seconds. Oh, okay. Well, if you want to produce 1,200 phones, that's going to take 360,000 seconds. We can't leave that's not really the answer to the problem, because the one thing that we should be mindful of is the problem did ask specifically for hours. Right, and actually that would be more intuitive or more helpful than 360,000 seconds. So again, this is just logic. If I said 360,000 divided by 60, that would reveal that it's going to require 600 minutes, right? Because there's 60 seconds in a minute. And then if I said, well, okay, fine, 600 divided by 60, there's 60 minutes in an hour. That's the answer to the question. It will take them 10 hours. If they want to create 1,200 smartphones daily, they need to run that line for 10 hours out of the day. Next question. What is the theoretical minimum number of workstations for an assembly line supporting Air Rules smartphone production? Okay, now they have an assembly line, it has 20 stations, but this question is asking for the theoretical minimum. That is the result of a formula. Capital N for the number of workstations, minimum though, the theoretical minimum. How do you calculate theoretical minimum? It's the sum of the task times divided by the cycle time. Oh, well, we do have that information. The sum of the task times is 400 seconds. That's what we were told. And the cycle time is 30 seconds. That's what we were told. Oh, and this is a really simple formula. In using this formula, just check that the number you put in the numerator and the number that you put in the denominator are referring to the same unit of time. Well, in this case, it is. There's no problem. It's seconds. All right, now, if I say, my calculator, 400 divided by 30, I get 13.333. With this particular formula, the theoretical minimum number of workstations, notice the funny looking brackets I put around the result, always round up. First off, we're talking about number of workstations, so we can't have a third of a workstation. We can't have decimal places. You say, well, then fine, I'll just round. And this particular problem, you would naturally round to 13. That's not the answer to the problem. If this formula comes out or results in anything other than a nice round number, then round to the next nice round number. That's why we declare that the theoretical minimum number of workstations for the Air Rules smartphone production line problem is 14. We bump it up to 14. What's that supposed to mean? It means that there are no designs out there that have fewer than 14 workstations. Now, remember, Air Rules already has an assembly line. It has 20. Apparently, they're happy with it. This is just another reading on their problem. However you were to design their line, there would be no way. We don't even know that there is a way to get it down to 14, but we know that there is no way to get it down to less than 14. All right. Now, last part of this problem. How efficient is the Air Rules smartphone assembly line? Now, the actual one, not this weird theoretical minimum one. Okay, when you're talking about an assembly line, efficiency is most easily calculated by taking the sum of the task times, that's how long it would take you to make one by yourself, and divide it by n, the number of workstations, times the cycle time of the workstation. Because the sum of the task times is how long, if you didn't have an assembly line, it would take you to create the phone. The assembly line is creating a phone every 30 seconds, but it's using n workstations to do it, so it's sort of like the total amount of labor each time it creates one phone. Well, what proportion is the first of the second? Okay, let's fill it out. Takes 400 if you don't have a assembly line. You're just doing it by yourself. The sum of the task times. Now remember, we are evaluating their actual assembly line, which has 20 workstations. That's what we were told. Each one of them taking 30 seconds each time it cycles. So that's 400 divided by 600 basically, or 0.66, or essentially, most convenient stated as a percent. The existing 20 station assembly line that Air Rules has set up is about 67% efficient.